all these three series. Then go to e-views, go to files, new, work files, right? Yeah, file in work files. Then is a balance panel. Start date is 1935 up to 1954, right? How many cross-sectional? 10. And you click OK. Then you can go to create and the group edit series. Before you paste, right? Because now we don't need to use that IND question mark, right? You can make the question mark. Still remember there are two approaches to key in the panel data inside. This is a one way, right? Use at the panel. Another approach is use the full object. Right. Go to the e-views here. Then you paste. Are you okay? Yes. approaches to key in. One is use the data, right? Then you key in like normal. Then we need to use a pull object. The other approach is use the balance panel here. Then start date 1935. End date is 1954. Yeah. So 1954. Then how many cross-sectional you have? 10. Then you click OK. So once you click OK, then you will note that there is a 200 observation, right? Because 10 years times 10 is 200. Then after that, we go to the quick and regroup and the series. Then when you reach here, we have to scrub. Right, because I need to paste that the variable name. So you copy the whole series for the column B up to column D for these 10 firms without the question mark. If you key the question mark, also no problem. Then you adjust in the e-views later. For the first series is investment, second is CFP, and then third one is BAL. So you just copy and then paste. So this is my series here. So double check whether is it got any empty place, nothing, right? So okay. So you copy and paste successfully. So what next? So the questions ask me to first has to estimate the model first, investment, VAL and CAP. Right. So I think I need to go to quick estimate equation. Then we can type our what we said that comment, right? First we have to start with our dependent variable investment, then followed by my constant, right? Then only start with the CAP and then VAL. So again, go to type of comments, investment, C, CAP, VAL. Then you will start to ask, what is C? C refers to the constant. C refers to constant. Why constant? Because in the e-view C is referred to constant. Right, so this is the comment. Investment is my dependent variable. And followed by my C, CAP, VAL. We have to start with the investment first. Dependent first, that will be followed by independent variables. Then your C you can put at the back here also can, middle here also can, as long as not the first thing. Then you say OK. But this is my pool result. This is my pool OS. So you can see the method here is panel this square. So can I test the cross dependency here? Cannot, right? When you go to view, maybe I check diagnostic for resident cross dependency. Yeah. So when you check for cross dependency, then you will find that there is a 3 test statistic: Bush-Gordon LM, Persaran LM, and the Persaran CD. So these are the 3 test statistics. Again, once you estimate, you click OK. Then I want to test whether there's a cross dependency in my analysis or not. So this means I want to check whether that what we said that the product movement correlation coefficient of the resident is it equals to 0 or not. So I need to go to view, diagnostic for the resident. Then once you click the resident diagnostic, there is a button here called cross-section dependency test. Then you click on that. Then this is my result, right? We make it bigger. So what is the hypothesis? No cross-section dependence in the residual as managed now. Because it's a diagnostic test, right? We should aware what is my hypothesis. Then you can see the conventional test, Bush-Gordon LM test with the statistic 231.24, degree of freedom 45, p-value is significant. Then how about the Persaran skill? I mean this skill, right? This skill, that is 19.6, also is significant. Then how about the corrected version? It means that which is the corrected version, percent CD, also 2.199, then significant at 5%. So no matter the conventional one, the traditional one, the skill version, or the which is a good power and size for the small cross-sectional and small T, which is the perseverance CD, 2.199, also significant at 5%. So based on these three CD tests, which is called as a cross-section dependency test, that shows that the result actually reject the Hirschsprung, right? Reject the Hirschsprung. So what it means? It means there is a cross-sectional dependence in the residue. So that the cross product, right, the product movement correlation coefficient of the residue actually is not equal to 0. Is it good? Is it good? We should expect that way, right? Because we are dealing with the panel analysis. Then you will start to ask, where's my boundary? So you still remember in the notes there, for this boundary at 2012, right? We have to estimate that the cross-section fixed effect. We have to estimate that the cross-section fixed effect only can perform the test statistic. So let's see how it works. We go to estimate, go to the panel option. We change that cross-section become fixed. We estimate the fixed effect models. Then you click OK. Once you click OK, the fixed effect models, then I go to View, then check for the diagnostic for the residue, the cross-section dependency test. So this is my test statistic for the fixed effect models. So any difference compared to the conventional test? Maybe compared to this totally different, right? Yeah. So as you observe, this is based on the pool least square. Based on the pool least square. So after we estimate with the pool least square, then we test the cross dependency, right? Then this is the test statistic. After that, the second slide here is an estimate with the fixed effect. So I allowed that the individual effect, right, for my residue, for my constant. So how about my residue? It will be different, right? So it will get a different set for residue for the fixed effect model. That's why the test statistic also changed. Was it right? Was it right? Rational. The test statistic will change because that the residue also changed. Because the two different models. One is the panel square, it means that the pool OS. The other one is based on the fixed effect models. So the test statistic based on the fixed effect models. Now I have additional one more test statistic, which is called bias corrected skill error test. It's proposed by the Baldaki et al. 2012. Give me that is return me that the test statistic is 21.146, significant at 1%. So based on these four test statistics, actually it shows that the Hirschsprung is rejected. There is a cross dependency in the residue. There's a cross dependency in the residue. Are you okay? Okay, right? So there's an explanation here. So the value actually is reject the Hirschsprung as a conventional. So that the Baldaki and also that the skill LM and Baldaki shows that you reject. But for our sample size, right, because we have the small sample size, or we only have 10 terms and very short sample, so the bias correction actually has not much effect in the test statistic. That's why in this sentence it actually support that the last considered good size and power, 4.7. So the test statistic 4.7 actually significant. It still reject the functional at the conventional significant level. So we can conclude that actually my models actually shows that there is a cross-section dependency. So if you're aware that there is a cross-sectional dependency, so is it the pool OS and also that the fixed effect models and random effect models still the results still valid? No, right? Because the result, as we aware that there are consequences if we ignore the cross dependency effect in our estimation. So your estimator in the pool OS in a fixed effect and random effect now actually is not efficient, right? Not efficient. And also the test statistic might invalid due to this cross dependency effect. Right? These are the consequences we just discussed in the group just now, right? Okay. So there is first additional diagnostic test instead of the Hausman test and also the Bush-Barton test. So now let's take a look at the control scarcity test. So how about control scarcity test? So in the EVC option, there's a button there, right? So you try to run the regression and then test for the control scarcity. we try? So let's try. So maybe I should wait for a while. Let me see whether it can run for random. Okay. So now I'd like to test for whether my OS, whether that my residual is it following the homoscedasticity or not. So I go to view and diagnostic for the residuals. Then choose the heteroscedasticity test. Choose the heteroscedasticity test. Then this is my result. How will it come? Yes. So my result here 467. Yeah, 467. Yeah. So it's significant, right? P value is significant. So under the H now, the residual are homo. So the residual follow the homoscedasticity actually means that the residual actually is the skew, the spread for the residual are constant. So as a H now, so now the P value here, probability here refer to the P value is significant. So we tend to reject the H now. Tends to reject, so the residual actually now heteroscedasticity. So actually it's consistent, right? Why? Because our result suffering from the obviously our model suffering from this cross dependency. So there is no surprise that we cannot pass the homoscedasticity assumption. It's normally complement to each other. So once our result shows that the cross dependency actually present in the analysis, so this heteroscedasticity normally present in our analysis as well. Because heteroscedasticity, right, will affect by this cross-sectional unit. So that's why there's evidence of this heteroscedasticity. Okay. So how about there's another test, it's called panel period. Just now it's a panel or is that cross-sectional, right? Yeah. Panel cross-sectional heteroscedasticity RR test. There is a panel period heteroscedasticity RR test. So it's just like a lot of different option, right? Go to the view, diagnostic for this residual. There's a period, yeah. So there's a period here. So also result is 49.95. 49.95 also shows that the residual actually is a heteroscedasticity, panel period heteroscedasticity test. So normally we will test for the first one. If you want to check whether there's a heteroscedasticity, what we more concerned is about the cross-sectional instead of the period heteroscedasticity. So now, how about the outlier? The third diagnostic test you can test is the outliers. Outliers here, if you use that residual plot, right, then you can, once you plot, you can observe that there is a first and then second and then third. Actually, it's referred to your cross section, to your firm number 1, firm number 2, firm number 3, number 4, up to number 10. So you can observe that actually the residual here for the firm number 3, number 3 here, right, and number up to number 10 is quite stable, right? Not say stable, but it's quite consistent as compared to firm number 1 and number 2. Maybe I can say number 2 is quite different compared to the other firms. The behavior for the residual. So is it the second firm? Is it the outliers amongst? It means that is it the second firm? Is it outliers within these 10 firms? Right. Because once it is a panel estimation, and then once I plot the residual from firm number 2, here, is a different, the behavior is different compared to the remaining 9 firms. So is it the firm number 2 is the outliers, right? So this is another way to detect for outliers. So this is just based on the graphical presentation. Actually, you can run some formal diagnostic test statistic which is to detect for outliers. So there's an additional test statistic to detect for outliers within the panel format. So this is just based on the residuals graphic representation. That's why you can take a look at the what we said right up here. So this just want to summarize that actually based on this residual plot is not that formula to check for outliers because it's very vague, right? It's very vague and also very difficult for us to judge the outlier from this what we say graphic representation. It's just a graph. Maybe I can say it's just an informal graphic representation from the residual plot. It's very difficult. You can say, yeah, group number 2 is an outlier because of different behavior, but it's better for us to complement with the test statistic. So there is a test statistic proposed by Lula 2015. So you can refer, if you have want to have know more about the test, you can refer to the Lula 2015. So before that, you can try to perform that the residual plot. So you can go to view here, and then choose the graphical representation, choose what we say, let me see. Yeah, actual fitted residue. Maybe I want to use that the residual graph. Yeah, just plot the residual graph. So after you estimate, right, you just need to go to the view and then choose that the actual fitted residue. Then there are 4 options here. Maybe if you want to replicate my graph just now, choose that residual graph. Choose that residual graph. So these are the residual graph. So again, these are the from number 1, number 2, number 3, up to number 10. So you can see here is a little bit different, right, compared to others. So again, the outlier actually is the extreme observation compared to the rest. Right? This is something like the layman language explanation for the outliers. Right? Layman language. Some people based on outliers and then exclude that particular firm slide from your analysis, it might change the result. It might make your autocorrelation, solve your autocorrelation issue or hydro scarcity issue. Right? So this is something like the discussion in the this field. So it's based on rule, right? There's a statement. There's a statement somewhere in the rule. So it says that the outlier can result the bias parameter estimate. So you have to solve that to detect it, which form actually is outlier might affect the result. So the details you can refer to that the rule 2015 here. Yeah, rule 2015. So this, I think I have outlooked the paper here, this one. Rule 2015 outlier patterns. Yeah, so many strange things, right? So at least you have some idea that there is a test to detect for these outliers. Okay. So actually, what else in diagnostic test you can test for your panel analysis? Not only cross-section dependency, heteroscedasticity actually got a serial correlation, but this one is for RNA unborn. Normally this one is for your huge N. Let's say it's 50 N, right? Then we run the GMM estimation. Then this is the option for you to test for serial correlation. Yeah. Then how about if you want to check for the normality to see whether the residue from your panel analysis are then normally distributed or not, then you can go for this histogram normality test. So once you click on it, so this is the Jack-Barra to check for this normality assumption. So this to check for the residual series in your panel analysis, whether follow the normal distribution or not. So based on the test statistic proposed by Jack-Barra, together with the p-value, the test statistic actually significant at 5%. So it's reject the hypothesis. So the hypothesis is your residual are follow the normal distribution. So this is my hypothesis. So this one we did not discuss in the lecture, right? So the question now is, the residual follow the normal distribution. Residuals follow the normal distribution. So this is my hypothesis. So the residuals follow the normal distribution as a Hershey-Knott. So this is proposed by the Jagdera. So the Jagdera statistic, so the p-value is 0.00. So 93.035 you can compare with the chi-square distribution to the degree of freedom, 5.9 at 5%. So it's significant at 5%. So it's going to reject a Hershey-Knott. So reject a Hershey-Knott, so I can say that actually the residual do not follow the normal distribution. So actually, what are the problems with my estimation? Or maybe I can say, what are the problems with your estimation? So based on your findings, still remember I asked you to summarize your result in the Excel format, right? Do you save the files? No, forget already, right? Maybe in the desktop, right? So once you run the regression, then you do the person test, then you found that actually your result actually support the random effect models, right? Based on our previous hands-on analysis, the result prefer the random effect models. But based on today's discussion, actually my model is suffering from this cross-dependency, right? Cross-dependency. So because that Aldagi at 2012, or Pasaran 2004, or Bush-Button test in 1980 also shows that actually there is a cross-dependency evidence in my analysis. Not only that, based on this heteroscarcity test, actually based on this either it's a panel cross-section dependence heteroscarcity, or based on this time cross heteroscarcity, also shows that there's evidence of this heteroscarcity. Not only that, my result, the residual also do not follow the normal distribution. So there are at least several problems here. Then based on the residual plot, also shows that the from number 2, actually there is an outliers evidence also in my graphical representation for the residual plot. So these are the something like the explanation you can explain right based on the diagnostic test. Yeah. So how to solve it? You have to solve it, right? Yeah. In order to come up with a valid conclusion, we have to try to solve this heteroscarcity issue. Maybe we can solve by using this this square method, or account for this use the correct standard errors, or maybe we want to remove the outliers, or we have to try to solve the cross-dependency issue by using a more appropriate approach, etc. So these are something like a solution for you to solve that particular issue. Okay, let's take a break, then we come back to our first generation panel unit test.